Hello everyone, welcome to Mayo Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is Night Dialer. So the problem statement goes like this: the chess knight has a unique movement. Uh, it may move two squares vertically and one square horizontally, or two squares horizontally and one square vertically. So these are the movements that are described for a knight in on a chessboard. Okay, so you from a particular cell, you can land upon eight cells. There are eight options that you can go from a particular cell. Okay, so this is one, two, three, four, five, six, seven, and eight. So there are eight options in total. Okay, so what the shape of the move of a knight is? It's a L-shaped move. Okay, so it's mentioned here. So the possible movements of the chess knight are shown in the diagram. Okay, chess knight move can be indicated as in the below diagram. So we have a chess knight and a phone pad as shown below. So this is a phone pad. So as of now, consider this as a chessboard with two square tiles removed, this star one and this hash one. Okay, you cannot place your knight at this particular these two particular locations. Okay, and in the blue ones you can place. So you are also given an integer n. Return how many distinct phone numbers of length n we can dial. So initially, let me copy this image. Initially what you can do is, let's say this is the dialer given to you. So initially you can place your knight at any of these tiles, and there is you have to form a n digit, uh, let's say phone number. Okay, so initially your knight can be placed at any of these. Uh, let's say you place knight here, then this knight can move in eight directions from this particular uh, point. Okay, so these will be the eight directions that your knight can move. Okay, as of now, I am not considering the actual cells that your knight will be in. So I am just showing the eight directions, eight possible moves of your knight. Okay, so these will be the eight possible moves. So now you have to form a n digit number. So for each digit of number, you will have each next digit of number, let's say uh, from left to right. What I mean to say is, let's say you are forming the number in this direction. Okay, these are the n digits. Then for each of these, you will be having eight options. 8, 8, 8, 8, 8, 8. And in total, how many options? How many numbers can be generated? 8 into 8 into 8. Okay, it will be continuing up to n times. So 8 raised to power n. Or you can say 2 raised to power 3 raised to power n. Or you can say 2 raised to power 3n. Okay, so these number of combinations will be generated if you go uh, for a brute force approach. Let's say you are trying to apply a brute force approach, and then these number of operations will be required to form a solution. And what you have to return is you have to return the number of unique numbers that you can dial of n length. Okay, so given an integer n, return how many distinct phone numbers of length n we can dial. You are allowed to place your knight on any of the numeric cells initially, and then you should be performing n minus 1 jumps to the dial to a dial number of length n to form a dial number of length n. Okay. So just I told this is just similar to what I told you. Initially, your knight can be placed at any of these blue cells, and then you have to make the jumps of knight and form an digit number, and excluding these two tiles. Okay, and so these number of operations will be required if you go for a brute force approach. Okay, so let's see what is the range of the n. N here is of range 5000. So this 2 raised to power 3 into 5000 will be a huge number as compared to the limit of operations, that is 10 raised to power 8 operations limit. So those of you who are new to this concept, whenever the number of operations required for your solution reaches to equal to this limit or exceeds this limit, then your solution will not be accepted and it may get a TLE, time limit exceeded, and it will not be accepted. Okay, and I will also be providing a link for an article describing how the time complexity of accepted solution varies according to input size. Okay, so what we have to do is we have to optimize this brute force approach in order to get our solution accepted. Okay, so let's say uh, let me clear the board first, or let's copy this image to a fresh slide. Okay, yeah, I think this one will be fine. Okay, so let's say your knight is currently placed here. So how could and you are at the, let's say, nth digit of the number. You are forming the nth digit of the number, and your nth digit of the number is 5, let's say. Okay, nth digit of phone number. Then how could you have landed up on this particular 5? There could have been 8 possible ways to reach 5. Those 8 possible directions of the moves of the knight. So previous state will be n minus 1th digit. Previous state. And this one is your current state. So in each of these states, there would have been a configuration of the board. Okay. So if you so there will be 8 possible previous states because of 8 possible moves. Previous states locations from where you could have in the current states cell. So in previous states there could have been 8 possible cells from where your knight could make a jump, and it would have landed on this particular 5 position. Okay, so let's say your knight can be placed here also. Let's say for example this is a valid, let's say for now this is a valid tile. Then if let's say in previous state n minus 1th digit your knight was placed here, then it could have made the jump. Okay, L shape jump. Okay, so I hope you are getting what I mean to say. Let me check how the knight moves. Okay, there is a no, I think it's correct. Yeah, so this could have been a previous cell in the previous state. So there would have been 8 options. So for each uh, nth digit, we will be adding contributions of previous states to the current state. So for each state or say digit, we will be adding contributions of previous state. Okay, previous state positions, 8 positions. Okay, so and once we have got the final digit n minus 1th digit, or you can say n minus 1th board also. In total, there will be n boards. So representing each representing one digit. Let's say there is a combination. Let's say we have to form a 5-digit number, and here is 5. Then let's say we form a number something like 2, 3, 4, 1, 2. Okay, these are the 5 digits. So your board configuration will be, there will be some board configuration in each of these. Okay, so you would have placed knight somewhere, only then you would have ended up in this particular combination. Okay, so for a n digit number, n boards will be there, and for each state or say cell, we will be adding contributions of previous state, 8 positions. Okay, so I know this is a little hard to visualize at first when you are new to this, but once you have get yourself accustomed to this particular type of visualizations, it will be pretty easier to think like that, and more will be clear in the coding part. Let's see how we have approached in the coding part. Okay, then once you have got the nth digit, or say n minus 1th board if zero based indexing is considered. You will simply add all the numbers present in the n minus 1th board. Okay, and that will be your answer of total number of unique phone numbers that you can dial. Okay. Initially, for the first board, for the 0th board, you can place your knight in every cell except these two. So rest all can be marked 1 because uh, from here you can start a valid n digit number. Okay, so let's see how the implementation goes. So I hope till now it's clear to you. If it's still not clear, I think it will more clear in the implementation part. So for each each n digits, each digit in let's say n digit number, you will be having one dialer for say board. Okay, so this will represent this particular thing, and then this mode will be required since it's mentioned in the problem statement that your answer can be very high. So you have to take modulo 10 raised to power 9 plus 7. Okay, and then initially for the 0th board, you can place your knight in any of the locations except star and hash. For 0th board, or say dialer, you can place your knight at any one of the blue cells. Okay, so I have just inserted one in all of the cells, and then in the remaining ones for each of the board, for star and hash in each of the board, for say dialer, I have inserted -1 to indicate that you cannot visit here. For each of the board, or say dialer, red cells are marked -1 for identification. Okay, then what you will do, you have already made the first move here. Here we have already made the first move. So then you will be starting from the second move. For second digit of n digit number, n digit phone number, starting from left to right direction. Okay, and these will be the 8 possible directions then in which your knight can move. Okay, and for each digit, you will be having one particular board. One board or say dial. Okay, dial pad, you can say. And then if let's say you are currently at the red cells, then you will continue. You will be not doing any calculations for them. For red cells in the board for current digit, board or say dial pad, you will not do any calculations. Okay, and then for the blue cell in the board or dial pad for current digit, you will add contributions of previous digits locations. Okay, for each cell, there could have been eight previous possible cells. Okay, for each cell, there could have been eight possible previous cells from which you could have ended in the current cell. Okay, so if this particular this you can change this r new to previous r also. That will be, I think, more appropriate name to give. Previous row. Let's change it. And this one also. Instead of C new, it will be previous column. Okay. So if it is a valid column, previous column, it is not going outside the boundaries of the board, and you are not on any red cell. If the previous cells are valid one in terms of them being blue and not red, then you will proceed and you will add the contributions of those cells to the current state cells. Okay, so and you will take mode of course, and then for the number of unique numbers, your n minus 1th board will be representing the nth digit, or say dial pad will represent nth digit. and for all unique numbers possible, or you can say instead of unique numbers, unique phone numbers. You will add all the values of n minus 1th tile pad or say board, and then you will simply return that number. Okay, this is just a boundary check and to check whether we are not in any of those red cells. Okay, let's have a sample run of the sample test cases. So it's getting accepted for sample test cases. Let's submit for the final evaluation. As you can see, it's getting accepted for the final evaluation also. So this is how we will be solving this particular problem. And if you ask what will be the time complexity, so time complexity wise, it will be at max what is the size of this particular board? So size of this board is 5000. Okay. And board dimensions will be 4 cross 3. Okay. So in total, these number of operations will be required, which will be less than the 10 raised to power 8 operations limit. Therefore, your solution will be getting accepted. And time complexity wise, it will be order of n into 4 into 3. Okay. And space complexity wise also, it will be n into 4 into 3. For the 3D array that we have just declared to store the previous states. And this particular approach of storing the previous state and avoiding extra work is called dynamic programming. Actually, what we are doing here is, let's say there is a phone number 1234, and let's say we are forming a 5-digit number, and there is another phone number. This is phone number 1, PH1, and there is another phone number, PH2, 1, 2, 3, 4, and then this is, let's say, 5. Okay, so only these two are differing, all of these are same. So you are doing computations again and again, uh, doing extra computations. Okay, and to avoid these extra computations, you could have just stored these computations to avoid extra work. This particular property of overlapping subproblems, subparts of a problem is called overlapping subproblem. Okay, this is one property required for dynamic programming solution. Another property that is required is, let's say you are forming the nth digit. Then it will depend upon n minus 1th digit. So it can be said that solution of big problem nth digit can be formed by combining solutions of smaller problems. Here there is only one smaller problem, which is small problem solution n minus 1th digit. So this particular property is called optimal substructure. For those of you who are new to these two properties, I will be providing links of article describing what these two properties are, and if these two properties are there, then we can apply dynamic programming, which is nothing but essentially storing the previous computations and then using those computations to of smaller states to build up solutions for larger states. Okay, so overall, four links will be provided: one for this optimal substructure, and then one for dynamic programming, and then one for this overlapping subproblem property, and one for that uh, concept of operation limit of 10 raised to power 8. Okay, so you can visit these links and have a clear understanding how we decided to apply dynamic programming approach on this particular problem, and how we saved some computations and arrived at optimal solution, which will be getting accepted also. Okay, if you are still having any doubts, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.